Okay, here is my solution to 30-Minute Mystery by Peter Scharl. This is actually my opponent for the next knockout round, so that will probably be game over for me. He's been making some really cool cases lately. This one is no exception. It's essentially like Cluedo-ish kind of murder mystery. You have a list of suspects and preferred accessory eye colour and all these metrics, and you have a game board that you will move around. That goes up to 40. So if we're at 40 and we move 2 spaces, we would go from 1 to 2. That's so we kind of want to loop on this. So I have a couple of lambdas for this. The first one is a board game move. So let's say I moved to 42 and the board has 40 spaces. I would end up at 2. So this is just a mod formula underneath here. So it's saying mod 42 with a divisor of 40. The only problem is when you actually are on space 40, it's going to give you mod 0. So you have to amend this to say -1 +1 at the end so that it works. So that's the reason I've got a lambda, so I don't have to do this -1 +1 thing. The second lambda I have, which has been used in a number of other cases, is a dice sum lambda. So I can say dice sum, if I spell it right, dice sum of any dice, and it'll give me the sum. I try and make my lambdas so they work on single things and arrays, so I can click that whole thing and it will give me the sum. I can even highlight all of this and it's only going to pull out the dice values. It eliminates everything else. That's just way easier for me, and it also works on big arrays as well. So stuff like this, there's a lot of dice there, it's going to give me the sum of all of them, so that's super useful. This is just finding the clue on the spaceboard, so a little bit of a setup. We'll call this clue, and this is always 1 to 40, so there's no gaps, so we can just use an index formula to do that. So index clue, this, and then the next one is a index match. You can do this many ways, but I don't know why I'm not typing equals today. Obviously slow. So we want this table, and we want to X match the suspects on here, and X match the thing on here. And let's just lock our table because I forgot to do that. These are the little things that slow me down and make me less competitive. I'm not very good at keyboard shortcuts, and not very good at like locking things and just slow to type brackets. All that stuff I need to improve somehow. Anyway, given a starting space, we want to find where we end up. So basically, if the dice roll is odd, you're going to have it's not that thing, and if it's even, then it is. I think that's the way around it is. So first of all, we just want to find where we are on the board. So all we're going to do is say board game move. We're starting on that space, and we're plussing a dice sum of this, and our board has 40 squares. So that's where we're going to end up. So then we want to do our index of clue, and that's going to give us what the thing is, so glasses. And then we want to say, so let's use a let, because if it can be a red herring, and if it's a red herring, you don't put a yes or no after. So let's say, I don't know, let A be that. If A equals red herring, do red herring. Otherwise, if is odd, dice sum of this A and no. Otherwise, need a bracket there. Otherwise, do A and yes. And that is our answer. I might start splitting this out because it's getting too long for me. This is the same thing, but we're going to use a longer string of dice. So I just want to find out if the last dice is odd. So is odd, I'm going to say dice sum of mid of that, and the start number is the length of that. I want one character, and I've missed a bracket there, so I think it will go there. Yep. So same thing as above, just a longer string of dice. Then what do we have? What is the clue after the X of the provided roll? So we want to do the same thing, but we want to take only kind of 18 of these dice. I don't know if mid actually works on this. Mid that, comma, start at 1, and the number of characters should be this. Yeah, I don't know why that works. But whatever, we'll do it another way. So all I'm going to do is I'm going to say equals split text this, which is one of my formulas that splits everything out into characters, and I'm going to take this many of them. So that's my new string. I'll concat that back together, concat. So I'm going to work off this string instead of the long string. So then I can just bring this back down here. I should be able to move this over to here. What is the clue after the first instance of consecutive rolls? I basically want to get everything out up to consecutive rolls. So I'll do this with a data table. Example 6. And then I want to say split text of this, and I'm going to say 1, and then I'm going to do equals if this equals this, do 1 plus this, otherwise do 1. So that's going to give me my sequences. So as soon as I hit a sequence, I have 2. So let's say x match 2 in this. That's going to give me 9. So I basically just want to do my take again. So take this, and I want 9. Whoops. Take this. Sorry. And I want, yeah, my 9 there. So I have all of those. Let's concat them again. And then I can just do exactly what I did above, basically. So I'm just going to copy the formula down here. And then that's in the right place. Oh no, it's on Y, so we've got something over here. Okay. So my starting space is, my starting space is here. Starting space of this, actually, that's a mistake. I need to do it over here because otherwise my data table won't work. I've made that mistake too many times now. And then let's pull that over to there. Okay, so that matches the example. That's a good start. Example 6. And the final one, moving backwards on each X roll. So let's just set this thing up again. Actually, let's just copy a bit more of it. So let's say example 7. That's looking into the right places. This is fine. Then let's do equals sequence. I think there's 30 dice rolls. It looks like that. And then I want to do equals mod that, comma 8. So if that equals 0, then it's a multiple of 8. Let's wrap it in a minus minus. Didn't lock my 8, so let's do that. I often forget to do that. Cool, so every 8 has a 1. So now I'll just say if that equals 1, do minus dice sum of that. Otherwise do dice sum of that. I missed a bracket somewhere. So then we have all of our dice rolls. So I'm just going to say equals sum of this, and then let's try and use this formula again somehow. So I'm saying our start space is 40, so we can just put 40 here manually. We don't need dice sum, we just need the 82. And then we want just the last dice here to determine if it's odd or even. So that should work. Yep. Okay, now we have to solve, now we have to figure out who the thieves are. So basically what we want to do is, from question 3, we want to match all these things to the suspects here. Where it's a yes, it means they do use that thing. Where it's a no, it means they don't. So you need to use the yeses and nos in combination. I spent about 30 seconds thinking how to do this with a formula, realised it would be really hard. I've since seen Bo's video where he did it, which is crazy impressive. But all I'm going to do is basically go through the yeses. So I'm just going to say filter this where this is not equal to red herring. And I'm just going to copy that for each of these questions here. Then we have this one. Have I got these as values? Yeah, so I can just delete this out. This is probably a slow way to do it compared to formula, but whatever, I don't care. So let's copy that to here and to here. Okay, so all I am going to do is I'm going to go through this. So I want sneakers, green, ketchup, cane, sneakers, green, ketchup, cane. So I need to eliminate either scarf or glasses. So glasses is a no, which means it must be a scarf, which is this person. And let's do the next one. So we have barbecue sauce, blue, and hat. So barbecue sauce, blue, and a hat is this guy. I think it's probably quicker doing this manually than figuring out a formula on the fly, to be fair. Now we have clogs and beanie. So clogs and a beanie. So now we need to use some of the no's. So if we could eliminate hazel, that would be good. Let's have a look. No, but we can eliminate cane, umbrella. Oh, so if we eliminate cane and umbrella, that leaves this guy. Now question 6. We have a yes on fan. Is that it? Yep, okay. So yes on fan. Now we just want to go through the nose basically. No scarf. No green, no barbecue sauce. No green, no barbecue sauce. No blue, no beanie, no relish. No blue, no beanie, no relish, not even there. So what do we want to eliminate? We can't eliminate anything there. Mustard, ketchup, beret, hat, something like that. So no mustard, that was good. So that leaves this one. Okay, and the final one, the last one, they're pretty much all no's. So no beanie, no loafers, no glasses. No beanie, no loafers, no glasses. No watch, no cane, no hat. No watch, no cane, no hat. No flowers, no sneakers, no umbrella. No mustard, no mayo, no brown. Oh, so we've got them. No mustard, no mayo. So it's this guy. And that should be it. Yeah, like I said, Bo did a crazy quick solution for that end bit, which was really impressive. I would never be able to think of that in a real thing, so that's the way I would do it. Cool, thanks for watching.